Let's now work through this example here. Example 1. An airline parks all its planes at Sydney Airport or Melbourne Airport overnight. The transition diagram below shows the change in location of the planes from night to night. This is also represented in the transition matrix T. So if you see here, if the plane is parked in Melbourne, then 80% of those will be in Melbourne the following night, when 20% of those will be in Sydney the following night. Likewise, if we start at Sydney, 48% will go to Melbourne the following night, while 52% will be in Sydney the following night. And now, with this information, we can create for ourselves a transition matrix. So as you can see, we've got 0.8, 0.2, 0.48, 0.52. So that must mean that this is going to be Melbourne, this will be Sydney, this will be Melbourne, this will be Sydney. So if it's beginning in Melbourne, there's an 80% of those beginning in Melbourne will remain in Melbourne, while 20% those in Melbourne will go to Sydney. And then over here, 48% of those that are in Sydney will go to Melbourne, and 52% of those that are in Sydney will remain in Sydney. So that is our transition matrix there. It then says, on a Monday, there are 80 planes parked in Melbourne Airport and 25 parked at Sydney Airport. Represent this information as an initial state matrix, so S subscript 0. So what that means is that I'm going to write in MS here. The reason why I know that the order is M up top and S here is because that's the order of it here. So that means I've got 80 initially in Melbourne and I've got 25 initially in Sydney there. So that is my initial matrix, the starting point from which I'm beginning from. It then says the state matrix describing the number of planes expected to be parked at each location n days after Monday night is given by this. So this is our recurrent relation that we're going to be dealing with now. It says complete the state matrix below to show the number of planes expected to be parked at each location on Tuesday night. Okay, so if we're dealing with Tuesday night, that means we're looking for S1 because, we're beginning on Monday and now we're going to Tuesday, so one day has passed. So to get that, what we're going to do is we're going to say, well, S1 is going to be equal to my transition matrix, which is simply what is written up here, multiplied by my initial state matrix. And that's what we're going to write here. So we're going to come here and I'm going to go 0.8, 0.2, and then my next one was 0.48, 0.52, and that is going to be multiplied by 80 and 25. And then we close that off. If I now come to my trusty CAS calculator and we put that information in, so we're going to come here, we've got a 2 by 2, and it is 0.8, 0.2, 0.52, and 0.48. And then we're going to multiply that by 2 by 1, and that's 80, and that's 25. What we're going to end up with is S1 is going to be 76.29. And this is going to be Melbourne, and this is going to be Sydney. So now we can come over here and let's just write down what we're saying. So we're going to say on Tuesday night, there would, let's try that again, would be 76 planes in Melbourne, and 29 planes in Sydney. Oh, that's a funny looking Sydney. Perfect. And that is it. That's how we apply our rule to get our answer. So we're using that transition matrix, multiplying it by an initial state, and we're getting the first one. Perfect. Hopefully you found this helpful.